What is ISO 5167? International Organization for Standardization (ISO 5167) is an international standard that specifies the measurement of fluid flow in closed conduits using differential pressure devices. Devices covered include orifice plates, venturi tubes, flow nozzles, cone meters. The standard defines design rules, installation requirements, flow calculation formulas, accuracy limits. What is the principle of orifice flow measurement? It works based on Bernoulli's theorem. When fluid passes through an orifice, velocity increases, static pressure decreases, differential pressure is generated. Flow rate is proportional to the square root of differential pressure. Q is proportional to the square root of delta P. What is an orifice plate? An orifice plate is a thin metal plate with a precise hole installed between pipe flanges. Its purpose is to create a restriction, generate differential pressure, enable flow measurement. What is the beta ratio? Beta equals D by D, where D is equal to orifice bore diameter, D is equal to pipe internal diameter. Typical ISO 5167 range, 0.1 less than or equal to beta, less than or equal to 0.75. Higher beta increase leads to lower pressure drop. What is differential pressure flow measurement? Flow is calculated using the pressure difference before and after a restriction. Measured using pressure taps, impulse lines, differential pressure transmitter. What are the main components of an orifice flow meter system? Orifice plate, orifice flange, pressure tapping points, impulse lines, differential pressure transmitter, flow computer or DCS. What are the types of orifice plates? Concentric orifice, most common type. Used for clean fluids, steam, gas. Eccentric orifice, hole offset from center. Used for slurries, fluids with solids. Segmental orifice, semicircular opening. Used for dirty fluids, suspended particles. What are pressure tapping methods? 3 common tapping methods. Flange tapping, 1 inch upstream and downstream from plate. Corner tapping, pressure measured at plate face. D and D/2 tapping, 1 D upstream and 0.5 D downstream. Why is straight pipe length required? Straight pipe ensures fully developed flow profile. Typical requirement: upstream 10 D to 20 D, downstream 5 D, where D is equal to pipe diameter. What is the discharge coefficient? Discharge coefficient, C, corrects theoretical flow. C equals actual flow divided by theoretical flow. Typical value, 0.60 to 0.62. What is permanent pressure loss? Not all pressure recovers after the orifice. Permanent pressure loss, 40 to 90% of delta P. This increases pump power consumption. What is Reynolds number? RE equals rho VD divided by mu, where rho is equal to density, V is equal to velocity, T is equal to pipe diameter, mu is equal to viscosity. ISO 5167 requires R greater than 5000 for accurate measurement. What is expansion factor? Expansion factor, epsilon, corrects compressible flow. Used for gas, steam, typical value, 0.95 to 1. For liquids, epsilon equals 1. What materials are used for orifice plates? Common materials include stainless steel 316, monel, inconel, carbon steel. Material depends on corrosion, temperature, pressure. What is vena contracta? Vena contracta is the point where fluid velocity is maximum and pressure is minimum after the orifice plate. It occurs slightly downstream of the orifice. What is the flow equation for an orifice meter? Q equals C times epsilon times A times the square root of 2 delta P divided by rho times the quantity 1 minus beta to the fourth, where Q is equal to flow rate, C is equal to discharge coefficient, epsilon equals the expansion factor, A is equal to orifice area. What are impulse lines? Impulse lines transmit pressure from tapping points to the DP transmitter. Requirements: equal length, no leakage, proper slope. How are impulse lines installed for liquids? Impulse lines should slope downward toward the transmitter. Purpose: prevent air accumulation. How are impulse lines installed for gases? Impulse lines should slope upward toward the transmitter. Purpose: prevent liquid condensation in lines. How is steam flow measured using orifice plates? For steam, condensate pots are installed. Impulse lines filled with water. DP transmitter measures pressure difference. What are condensate pots? Condensate pots maintain equal water columns in impulse lines for steam flow measurement. This ensures accurate differential pressure measurement. What are common errors in orifice flow measurement? Errors occur due to incorrect plate orientation, purrs on plate edge, blocked impulse lines, incorrect tapping location, improper straight pipe. What is turndown ratio of an orifice meter? The turndown ratio is approximately 3 to 1 to 4 to 1, meaning maximum flow measurable is about 3 to 4 times minimum flow. What is square root extraction? Flow is proportional to the square root of differential pressure. Flow is proportional to the square root of delta P. DP transmitters perform square root extraction to output linear flow signal. Why is edge sharpness important in an orifice plate? Sharp edge ensures proper flow separation. If edge becomes rounded, discharge coefficient changes, measurement error increases. What are advantages of orifice plates? Advantages: low cost, simple design, no moving parts, suitable for high temperature, international standard available. What are disadvantages? Limitations: high permanent pressure loss, limited turn-down ratio, sensitive to wear, not suitable for dirty fluids. What calibration is required for orifice plates? Usually no calibration required if manufactured according to ISO 5167. However, plate inspection, DP transmitter calibration, impulse line maintenance are required. What is flow computer? Flow computer calculates flow using differential pressure, temperature, pressure, density. Used in custody transfer systems. What is the accuracy of ISO 5167 orifice flow measurement? Typical uncertainty, plus or minus 0.5% to plus or minus 1.5%. Accuracy depends on correct installation, proper plate design, stable flow conditions. Thanks for watching. Please subscribe, like, share, comment. IIQA